Assalamualaikum. We are from Group Ege. We'll be presenting about our Emt project. Our group members are Chong, me, Muhammad FAHMI FUAD, Shan, and Tanzi.
Now I will briefly introduce our experiment concept. Our experiment is actually about solenoid. A solenoid is a long piece of wire which is wound in the shape of a coil. When the electric current passes through the coil, it will create a uniform magnetic field inside the coil, and the use of coil of wire will produce a relationship between electricity and magnetism that gives us another form of magnetism called electromagnetism. So there are a few factors which can affect the strength of magnetic field. The first theory is number of turns. When there are more number of turns, which means more coils are added, the magnetic field lines will become stronger because individual units will sum up together, and this result more current will passing by. And we can see from the relationship H equals to I times N over L. When N increase, H will also increase. The second theory is about the voltage. When voltage increasing, the current will be increasing also. So when current increasing, it will result in stronger magnetic field. This can be also proven by the relationship as shown in the slide. The third theory is about the diameter of a coil. A larger diameter of a coil will have larger surface area and it will pass more current through it. And more current will result in stronger magnetic field. And these are the few factors which will affect the strength of the solenoid and also affect the strength of the magnetic field.
The magnetic relay, as shown in the figure, applies the principle of an electromagnet. Overall, the electromagnet in a magnetic relay is generated by passing an electric current through a coil of wire, creating a magnetic field that interacts with a ferromagnetic core and controls the movement of the relay's mechanical components. The direction of the magnetic field depends on the direction of the current flow through the wire. This mechanism enables the relay to switch electrical circuits on and off in response to changes in the current flowing through the coil. The next application is magnetic resonance imaging machine. MRI machines use superconducting coils that exhibit zero electrical resistance when cooled to extremely low temperatures. This extreme cooling is necessary to enable the superconducting material to conduct electricity without any resistance. Once the superconducting coils are cooled to their operating temperature, an electrical current is passed through them. Since there is no resistance in the superconducting material, the current can flow without any energy loss. When a current flows through the superconducting coils, it creates a strong and uniform magnetic field around the coils. The shape and arrangement of the coils determine the specific characteristic of the magnetic field, such as its strength and spatial distribution.
Hi, I'm Tanzi. Now we would like to start the experiment. So before we start the experiment, let me introduce the material that we've used in the experiment. First is the staple bullet, and then cellulose tape, two 1.5 volt batteries, and a nails coil by copper wire. So to prepare the nails that can be used in this experiment, you need to coil the nails by using a copper wire to let him become the solenoid. Now we come to the most important step in this experiment. First, we need to remove the insulations on the copper wire before we start the experiment. We need to remove the insulation in the two tips of the copper wire to let it conduct electricity. This is how we remove it. Now, what FAHMI is doing now is he is connecting the circuit and let them to attract the stepper bullet, and then we will calculate the number of stepper bullet that is attracted. Now he is using 1.5 volt battery, diameter of copper wire is 1 millimeters, and the number of turns of solenoid is 70. Now we change the number of turns of the solenoid into 35 turns, and then we remain the original voltage, which is 1.5 volt, and then the diameter of copper wire, which is 1 millimeter. So the number of stepper bullet attract is calculated. So this is the result we get from the above experiments, and now we can show shown that the more the number of turns of solenoid, the more the electromagnetic field is created, and the more the number of stepper bullet attract. So now what Bowie is doing is she is using the diameter of copper wire with 1 millimeters, number of turns of solenoid is 70 turns, but we change the voltage, which is responding variables, to 3 volt to observe the result. Now, number of stepper bullet attracts for 1.5 volt is 63, but for the 3 volt, number of stepper bullet attract is 73. So we can have proof that the voltage increase, the electromagnetic field produced will also increase. So the last experiment which I'm doing is she changed the diameter of copper wire to 0.5 millimeters, and then the battery remained as 1.5 volt, and then the number of turns of solenoid remained as 70 to observe the difference. So this is the result we get from the above experiment. So we can see that when the diameter of copper wire decrease, the number of stepper bullet attract is also becomes less. So it can show that if you have a large diameter of copper wire, you will produce a large electromagnetic fields. So you can attract more number of stepper of bullet. So from this experiment we have done and the result we get, we can conclude that the voltage, number of turns of solenoid, and the diameter of copper wire is the factors of strength of electromagnetic field on the solenoid. The higher the value of this factor, the more stepper bullet attract, and this shows that the stronger electromagnetic field is being produced. So our experiment is success. Thank you.
That is all from us. Thank you for watching. I am Muhammad Fahmi Afam and this video is edited by me.